Right, guys, if you could comment your names. Sorry about that. I'm just it's got 1% now, so I'm hoping it's going to work, but I don't want to turn it on until we absolutely need it because it might go off again. So we're looking at partial fractions again today, which is what we started, what we finished on briefly at the end of the last lecture. So I think most of you commented. Let's do the register, and then we'll hope that the battery lasts. All right. So we've got Jay, we've got Guy, we've got George and Danny, Elliot and Nuala, Chloe and Lucy, Billy and Harry, Louis, Ollie and Jake. Cool, so just missing Tristan and Callum, and I think the other guys emailed me to let me know what's going on. Cool, okay. Right, okay, let's give this a go and hope this works. If it doesn't, I'm gonna have to rig up some paper. Yeah, we'll hope it works, basically. All right, you can see we're on. Oh no. Oh well, we'll see what goes on. Cool. All right. So I think we'll do one more example because you guys saw how to do this, but I think one more would be good. So we're going to try and split. So partial fractions is the title. I might just put my old iPad on charge so there's a backup in case this goes down. So stick that. All right. So we're going to try and split 5 over x plus 1 x take 4 into partial fractions. So we're going to split it up into two fractions. One of the denominators is going to be x plus 1, so a over x plus 1. The other denominator is going to be b over x minus 4. So what we're trying to do is to find out what a and b are. And when we do that is we add these fractions together with a and b, kind of algebraically, then we compare them to what's on the left-hand side and use that to solve for a and b. So I'm going to cross multiply and add the two fractions together. So we get 5 over x plus 1, x take 4 equals a, x minus 4 plus b, x plus 1, all over x plus 1, x minus 4. So we've cross multiplied and added them. When you get comfortable with these, you can skip this step and go straight to the step I'm about to write. So when I do these, I would normally go straight to 5 equals a, x take 4 plus b, x plus 1. Because if they've got the same denominator, we can just equate the numerators. Don't ever skip the first step. Students do, and if they skip the first step, they quite often, when they finish the question, get their A and their B the wrong way around, and it loses them the marks. So always do the first step, always do this step, but you can miss out this interim step here. Right, so we need to try and find out what A and B are. What we're going to do then is we're going to substitute different x values into that bottom equation. So if I want to find b, we need to get rid of the other unknown, which is a. So if we want to get rid of a, we're going to make a be multiplied by 0. So we're going to make that bracket equal 0. So we're going to say let x equal 4. So we're going to get 5 equals, the a bracket's going to disappear, plus b lots of 4 plus 1, which is 5. So 5 equals 5b Therefore, b equals 1. So I can go back up here and I can change this into a 1. You guys would just rewrite this. Rewrite it at the bottom. Okay, now we need to do the same thing with the A bracket and B bracket. So we want to find A, so we need to make B disappear. So we're going to let x equal minus 1. So we're going to get 5 equals A minus 1 minus 4. So 5 equals minus 5A. Therefore, A is minus 1. And we're going to write that at the top. Minus 1. And then we're done. That's it. Anyone got any questions? Because you guys are about to try 2 of these. So ask me now if you've got any questions. No? Okay. Alright, I'm going to write 2 up quickly and then you guys can get started. So, express. Let's get rid of that. Cool. So 2 there to do. First one, you need to factorize the denominator before you start. And for the second one, it's got 3, so you're going to need 3 separate fractions. Right, I'm going to give you guys 10 minutes to try these. Please comment if you need help, and please also send me photos of your answers. The timer starts now. Right, how do we get on, guys? Anyone need any help? Or I can't see any answers sent to the Teams chat yet. So if you guys could do that. Oh, there we go, cool. So, expressing these two as partial fractions. So the first one we need to factorize. So I think this one's going to be a plus 5 minus 3. So if you get these the other way around, don't worry. Just it means your A will be different to my A. Cool, yeah, keep sending them in, guys. I've got a couple answers so far. So then I'm going to do that skipping step. So I'm going to go 2x take 14 equals ax plus 5 plus b x take 3. Let x equal 3 first of all. So we get 6 take 14 equals 8a. 6 take 14 is going to be, what was that, minus 8? Yeah. So therefore a is minus 1. Then we do the same thing for b. So we're going to substitute x is minus 5n. So we get minus 10 minus 14 equals minus 8a. So minus 24 minus 8a. So therefore a is 3. Wait. B. I wrote a instead of b. That should all be b. So yeah, b is 3. So let's write it in there. So that is the first one done. Let's have a look and see how you guys did. Lucy, yep, spot on. Jay, looks good to me. Remember to write out the final fraction though. You've done all the hard work, but you need to do that last step and write it. Write this bit. Guy, let's rotate my neck. Yeah, nice, good. Harry, good. And Elliot, good. Yeah, Elliot as well. You need to write the last step, so just make sure you write that final bit. Okay, let's do the other one. So the other one is more long-winded, but it's not really any harder. So we're going to split this up into three fractions, as I should say. 2 2x squared minus 12x minus 26. It's a over x plus 1 plus b over x take 2 plus c over x plus 5. So let's skip that stage. So 2x squared minus 12x minus 26 equals a. Now we're going to need to cross multiply everything here. So we're going to need a times x minus 2 x plus 5. I'm going to run out of room. Let's just rewrite some stuff. So I don't really need that anymore. Cool, there we go. So yeah, the major difference here is that you're going to have to times each one by 2 other fractions to get those 2 other parts there. All right. So we're going to have to do 3 different substitutions. First substitution, let's say x equals 2. So we're going to get 2 lots of, so we're going to get 8 there, take 24, take 26 on that side, equals, so the A is going to disappear, the C is going to disappear, we're just going to be left with B times 2 plus 1, which is 3, times 2 plus 5, which is 7. So 8, take 24, take 26, so we get minus 42 equals 21b, therefore b is minus 2. Right, let's do the next one. So now we're going to substitute minus 1 for x. So we get 2 lots of minus 1 squared is 1, so 2 plus 12 minus 26 equals b and c disappear, so we get a times minus 3 times 4. So minus 2 equals minus 12a, therefore a equals 6. And lastly, C, so we need to substitute in x equals minus 5 this time. So we get 50, take 60, take 26, equals a term and b term disappear, so we get c times minus 4 times minus 7. Then minus 36 equals 28c, I think that's right. Let's double check this because the others were all whole numbers. Oh, that should be a plus, shouldn't it? Yeah, okay. Which gives me c equals 3. Yeah, I thought that's wrong. Sometimes it can be a fraction, but pretty sure this one wasn't. Cool, there we go. So that's that one. Let's have a quick look and see what you guys have done. So Harry did it, and Harry, you got different numbers to me. What do you got? You got Yeah, Harry, can you see anything you did wrong here? I don't think, Harry, that you put your x's into the left-hand side. It looks like you kept the same left-hand side every time. So have another look over that one. Who else did it? Lucy. Lucy was slightly different. Wow. Yeah, I agree with your C. But the other ones I don't agree with, so maybe I've made a mistake. Yeah, real quick, so if me and Lucy agree on C, I'm just going to have another look at my A and B. I might have made a mistake. It's easy to make mistakes in this. You've got to be really careful with your signs. Let's try x equals 2 again. Real quick. So we're going to get 2 lots of 2 squared. 2 squared is 4, 2 times 2 is 8. So we're going to get 8, take 24, take 26, equals b, 2 plus 1 is 3, 2 plus 5 is 7. Use calculate for this so I didn't make any more mistakes. Minus 42 equals 21b. Therefore b is minus 2. No, I still get b is minus 2. And real quick, let's check the other one. So this time we're putting in x is minus 1. So we get 2 plus 12 minus 26 equals a lots of minus 3 minus 4. Oh, I do get this one different reason, minus 12a. So a should be 1. Cool. So yeah, 1, minus 2, and 3 is what I think you should be getting. Yeah. So Lucy, have a check through. I think something's gone wrong with your calculation of b there. I think just have another check of that one. Cool. Right, I'm going to give you guys, what time are we on? Yeah, we'll do 2 more. I think 2 more is fine, and then we'll move on and make it slightly harder. So, express in partial fractions. We'll start with this one. No, let's not do that one. That's going to be too hard, I think. Right, so we'll start with this one. I'll give you guys 5 minutes for this. Before I go through it, I just want to kind of draw your attention to the fact over the summer holidays, we always set our students some work to do, like you guys did before you joined first year. You now have summer work to do before you join second year. I've put it up on Moodle. It's basically a load of past exam questions on each topic, and then there's a test at the end. Test at the end is what we want to collect in. So you need to do the questions to prepare, do the test at the end, and you need to bring that test in on your first day back after summer. And there'll be a test on that summer work in the first lecture. It's really important you get that done and you revise for it. It's basically to keep your maths knowledge up to date over the summer, and also because this term's been so weird, it's going to be really important that we know that you guys have actually learned all this stuff. So the videos are still here, so you can rewatch these videos as many times as you like. I'm also doing video solutions for that summer work currently. I think I've done 2 questions so far, but the rest will go up sometime this week or next week. But yeah, so if you go onto Moodle, it should be at the very top now. Summer work, PDF version, should have the answers there as well, and then there should be a link to the video playlist as well. So if you guys can make sure you get that done over the summer. I wouldn't start it too soon because you want to make sure it's still fresh in your mind when you come back in September. If you do it soon, just make sure you look over it again when you come back. But yeah, make sure you get that one done, guys. That's kind of like mandatory over summer homework. Right, so 5 minutes to try this one, starting now. Don't forget to post your answers, guys. I'll give you a couple of minutes just while I wait for some answers to come in, because I want you to all have had a fair attempt at this one. So a couple more minutes while you get your answers sent over to me. Any more answers? Still, I've got one sent in, which if people are stuck, ask for help. But I do want to see some more stuff. So George, thank you. You sent yours in as well. Good. All right, we'll go for it slowly. But the next one we do, I want all of you saying something. Either I'm stuck or here's my answers. So, I'm going to turn this into a over x plus b over 2x plus 1 plus c over 3x take 2. And we can again skip the next step. So we need minus 10x squared minus 8x plus 2 is a times 2x plus 1 times 3x take 2 plus, again around space here, plus b times x times 3x take 2 plus c times x times 2x plus 1. So when you're doing this, basically every one of these, c needs to be times by the other two denominators, b needs to be times by the other two denominators, a needs to be times by the other two denominators, because we're trying to get the denominator for each one of these fractions to be this. So if it's got a bit of it already, you're just timesing it by the other two. If it's got a bit of it already, you're just timesing it by the other two. And that's how we do that first step. Then when we've got that, we can now just make some substitutions. So I'm going to do them all down here. So we're going to let x equal, for the first one, let's make x equals 0. And this is going to cancel out b and c. So we'll get 2 on the left-hand side equals a times 2 lots of 0 plus 1 is just 1. And 3 lots of 0 take 2 is just minus 2. So 2 equals minus 2a, therefore a is minus 1. Good, got lots of answers coming in now. Thank you, guys. So I'll put minus 1 in as a. And now we're going to go back to it and try the other two. So put in x is 2 over 3. So we're going to use a calculator for this one. We're going to get minus 10 times 2 over 3 squared. That's going to be minus 40 over 9. Minus 16 over 3 plus 2 equals, and we're going to be left with the c term, equals c times 2/3 times 2 times 2/3, that's 4/3 plus 1. So a lot of fractions in this one. So minus 40 over 9, take 16 over 3 plus 2 gives me minus 70 over 9. That equals c times 4/3 plus 1 is 7/3 times by 2/3 is 14 over 9. So if I divide minus 70 over 9 by 14 over 9, I get C is minus 5. So let's write that in. And lastly, we need to substitute x equals minus a half. Type it in, minus 10, lots of minus a half squared, plus 4, plus 2 gives me 7 over 2 on the left hand side. So B is going to cancel, no sorry, A is going to cancel out, C is going to cancel out, we're looking for B, so we get B times minus a half times 3 lots of minus a half, take 2, which is minus 7 over 2. Cool. This gives us B equals 2. There we go. Right, see what you guys said. So Lucy, yep, I agree with exactly what you've said. George, I agree with exactly what you've said. Harry, yep, agree with exactly what you've said. Guy, I agree with exactly what you've said. Louis. Some of it, Louis. A is right, B is not right, C is not right. So have another look through. I think you've just put your... what have you done? I think you've just put it in wrong into the equation. Yeah, you've got a sign error. Can you see that, Louis? You've copied it down as plus 8x, but it should be minus 8x. So your method's probably correct, but you've copied it wrong. Yeah, you said that as well. Cool. All right, well done, everybody. Right, I'll try one more, then we're going to make it a bit harder. Or a bit different. It's not really harder. This topic's quite an easy topic once you've got your head around it. Okay, let's go for this one. So another 5 minutes starting now. See if you guys can get this one. You either ask for help or send me your answers. Cool. Right, let's go through this one, and then we're going to change the difficulty a bit. So first thing we need to do is factorize the denominator. Which doesn't look as easy on this one. What are we going to have? It could be 5 and 2, it could be 10 and 1. Let's think. What are we going to have? What have we got? It could be 10, 1, 5, 2. And then we've got 4s, so it could be 2 and 2, or 4 and 1. Yeah, it's going to be, isn't it? It's going to be 4 and 1 there. Cool. Sorry guys, that took me a little while to see. Yeah, so factorizing that one, we're going to get 5x. Is that right? 5. My brain's not working out. 5 to 8 there to get us. Do I mean 2 and 2? 10, 10, 5. Okay, yeah, so we need a minus there. So that's there. So there'll be 5 minus 5 plus 8, which will give us 3. Yeah, cool. Okay, so it's 5x plus 4. 2x take 1 as the denominator. So we're going to be splitting this up into a over 5x plus 4 plus b over 2x take 1. And the next step, 8x plus 9 equals a 2x take 1 plus b 5x plus 4. So we should get that for what we're trying to actually solve. Do you guys want a bit more time? Okay, I'll give you 2 more minutes. Cool. All right, so yeah, we're going to sub in some stuff. So we're going to let x equals a half. So we're going to get 4 plus 9 equals b times 5 over 2 plus 4. So 13 equals 13 over 2b, therefore b equals 2. And same thing there with the other one. We're going to let x equal minus 4/5. Alright, b is going to disappear. So working all this out on the calculator, 8 lots of minus 4/5 plus 9 gives me 13 over 5. Minus 8/5 take 1 gives me minus 13 over 5. A, so therefore A minus 1. Ah, I forgot to write down what B was, I deleted it. I'll look at what you guys got. So A should be minus 1. And B should be, before I deleted it, why did I delete it? Wait there for a sec. Alright, let's have a look and see what you guys have done. So Harry, I think yours looks good. Yeah, B was 2, wasn't it? Yeah, B is 2. Yeah. Cool, good, Harry. Jay. Yeah, nice. Elliot, nice. Louis, nice. Cool, alright, well done, everybody. George. Yeah, nice. You gotta be careful. I think I saw your first version, George. You gotta be careful if you're solving on the calculator. You got to put in like fully factorized form. You can't just always do x take away whatever you got. So be careful of that. Right, a little bit of time left. So I'm gonna try a hard one. We're gonna, yeah, we'll see what happens with this one. So we're gonna try and do this one. I'm gonna put a little title here. We're gonna call this repeated roots. So e.g. 2x plus 9 over x take 5 x plus 3 squared. My question to you guys, what are the fractions? What are the denominators? So I'm going to give you a couple minutes to think about it. What would you put if you had to just do this one? What would you use as your denominators? So 2 minutes, have a quick think. Right, we've had some suggestions. Alright, Elliot, I'm going to show you what's wrong with your suggestion. It's a nice suggestion, I'm glad you made it, but it's not going to work. I'll show you why. So we take Elliot's suggestion, a over x minus 5 plus b over x plus 3 plus c over x plus 3. How do you add fractions? What do you need in order to add fractions? Do you guys remember? To add two fractions, you need a common denominator. Yeah? B and C already have a common denominator. So what I could do, because they're the same fraction, to add those, I would just change this to B plus C over x plus 3. And that definitely isn't the same, because we've got 3 terms on the bottom in the left-hand side, only 2 here. So that's not going to work. It's a nice idea, everyone always suggests that, but it doesn't work. George has said we just split it into 2 things. I mean, that's kind of the same as what, that's the result of what Elliot just said. So you're saying x minus 5 plus b plus c over x minus 3. Again, it's a nice idea, but it doesn't give you enough terms on the bottom. This will give you a quadratic. We've got a cubic on the bottom. So that doesn't work either. Any other suggestions? Or any other guesses? Right, I will give it away because we are running out of time today. I would like to get through this one. If there are repeated roots, and this is really important, what you do we use the repeated root in its squared form and in its linear form. So in other words, we do a over x take 5 plus b over x plus 3 plus c over x plus 3 squared. That's how you have to do them. It's weird, I know, but that's the only way that these work. So you need to use the root squared and the root on its own. And that's how you do these repeated root questions. Now the rest of these are pretty much the same. The only difficulty we're going to run into is, well, let's see, if you guys could try the next step. So if you could write out the equation, I want you to try and write out 2x plus 9 equals, and then whatever you think it is. Another 2 minutes, can you guys try the next step? Right, any ideas, guys? What's Louis said? Can we make x plus 3 times x plus 3 squared and x plus 3 cubed? No. No, because they're being added, they're not being times. Otherwise we could. Okay, where this is kind of confusing then. Before what we did was we just cross-multiplied, yeah? You can't do that here or you'll get too many things, too many terms. So in each case we need to say, what do I need to times this fraction by to get this denominator? So I need to times a by x plus 3 squared, because it's already got the x minus 5 on the bottom. Next, b, what do I need to times this fraction by to get this denominator? Well, it's got x plus 3 already, so we need one more x plus 3, and we need the x minus 5. And how about c? Okay, well, c already has x plus 3 squared, so it's got this bit taken care of. So for c, we're just timesing c by x minus 5. So that's what my kind of the next step is to get this. Okay, and then it's kind of similar to before. There's going to be one more difficulty though. So what values could we substitute in? Well, we could substitute in x equals 5. And if I put x is 5 in, it's going to make this one disappear and this one disappear, and then we can find a. So that's fine, we can find a by using this. I could then let x equal minus 3. And if I let x equal minus 3, this one's going to disappear, this one's going to disappear, and we can find c. So far we found a and we found c. How can we find b though? We've substituted everything in. So at that stage it's a bit harder. So we do that to find a, we do that to find c. So find a, find c. How we find b is we put in a and c and make x something easy. I would always say make x equals 0 or 1 or minus 1, something you haven't already put in. So in this case 0 would probably be my first choice. Make x equals 0 and then we can then solve it. So I'm going to give you guys 5 minutes, see if you can solve this one, find a, b and c. Be careful, I talked you through what's difficult is this bit here of finding the last one, but you put in the values you've already found and make x something easy. That'll give you just one unknown, and then you can find out what b is. So if you guys would like to give this a go. Uh, 5 minutes starting from now. Right, let's go for this one. So I've had George sent his in, but we'll get through it because we only got 6 minutes left. So 2x plus 9 equals a x plus 3 all squared plus b x plus 3 x plus 5 plus c x plus 5. So start easy, we're going to do x equals 3, x equals minus 3. So we get minus 6 plus 9, which is going to be 3, equals c lots of minus 3 plus 5 is going to be 2, so c equals 3 over 2. Then we're going to let x equal minus 5. Oh, hang on. It should be, I made a mistake there. So we're going to let x equal plus 5. So we're going to get 10 plus 9, which is 19, equals a times by 3 plus 5, 8 squared. This one's going to be horrible, isn't it? So 19 divided by, that is 19 over 64. Not sure you know about that. Cool. And lastly, we're going to put in x equals 0. You could choose anything. 0 is a nice easy one though. So we're going to get 9 equals 19 over 64, which is a, times by 9, plus b times by 3 times minus 5 is going to be minus 15, plus 3 over 2 times minus 5. So I'm putting in a and c and x equals 0. Right, we're going to need a bit of space for this. Well, actually, we can probably just do it on the calculator. So 9 equals 19 over 64 times 9. God, this one's going to be horrible. Is this right? Wait, I've made a mistake with c. Hang on. Minus 3 minus 5 is minus 8. Not 2. So c is actually 3 over minus 8. Minus 3 over 8. Okay, it's a good thing I corrected that there. So that should be down here. Okay, that makes things look a little bit better. So 19 over 64 times 9. Take away 3 eighths times, I'll actually add 3 eighths times 5. Cool. And we'll do 9, take that. Divide by minus 15. So we get b is minus 19 over 64. So those are all the bits. We can write them in at the top. Yeah, let's make some space actually. So if I get rid of all this. So yeah, sometimes they do come out as horrible fractions. It's always worth checking if they do, but I think in this case they do just come out like that. So our answer is going to be 19 over 64 x take 5 minus 19 over 64 x plus 3 minus 3 over 8 x plus 3 all squared. That is my answer. Cool. Right, so George, yeah, well done. Louis, I think your A's come out wrong. Have another look for your A there, because I think that's cost you. Your C's right though. But yeah. Cool, right, that brings us to the end today. So next lecture, we are still going to be looking at this. And there's one more little bit to this topic, which we're doing on Friday. Go on Moodle, have a look for the summer work, just so you know where it is. And if you guys could do this week's assignment and skills check as well. So you should be all up to date, all assignments and skills checks finished by Friday, not including the assignment on this topic, which I'll be setting over summer holidays as well. If you are at all behind, fine, but get it done as soon as you can so that I can mark it over the summer. Right, see you guys on Friday. Cheers and thank you. Bye.